Hello friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2371. Minimize maximum value in a grid. So in this video, we're going to share a method. So essentially it's a greedy method. So we actually set the value of position RC from small to large. So here, this problem is marked hard by Leetcode. So actually, if we analyze this problem a little bit, so this is not that hard. So here, we are given an m by n integer matrix called grid containing distinct positive integers. So this is an important information. So here, the task is the following. So we want to replace each integer in the matrix with a positive integer satisfying the following two conditions. First, the relative order is maintained. So the relative order of every two elements that are in the same row or column should stay the same after the replacements. And secondly, the maximum number in the matrix after the replacement should be as small as possible. So here are some instructions, and we are required to return the resulting matrix. And if there are multiple answers, we can return any of them. So here is two examples. So example 2 is basically a trivial case. And let's look at example 1. So we can first set this corner, so 1, so this remains 1. And we can set this 2 by 1, and then this 3 by 2, and this 5 by 2 again. So this is the result. And let's also look at the constraints before we write the code. First, m and n are the number of rows and number of columns in the grid. So m times n is bounded above by 10 to the power 5. In other words, we have at most 10 to the power 5 positions to reset. And the grid consists of distinct integers. So this is actually an important one. So basically, this specifies the size of the problem we're looking at, and this gives us some good information. So with that said, let's look at the method we are going to present. So the method is to set the positions according to their values. We want to first set the positions RC with smaller value, and then gradually set the positions with larger values. So the idea is the following. So we are going to maintain the relative order or monotonicity of numbers in each row and column. So we update the grid values from RC with smaller values to those with larger values. So this way, actually, we could maintain the relative order in both row direction and column direction. So that's why we need to do some sorting according to the value of the grid. This is the first part. The second part is that we can maintain two lists, each recording the current minimal values of the rows and columns when we set and update a position RC. So when we set the next position RC, we use the pre-updated value plus 1. So that's basically the overall thought. So this way, we could make all the values as small as possible. Of course, a priori, we maintaining the relative order in step 1. So that's the main idea. Basically two steps. The first one corresponding to a sorting, and the second one corresponding to the check and reset. So the procedure is as follows. So the code will speak itself, so we directly go to coding. And here is a follow-up. Actually, for this problem, we are specifically using sorting because of the size of the problem. That is, m times n is bounded above by 10 to the power 5. So if we want, actually, we can use bin heap data structure, but not absolutely necessary here. So now let's look at the code. First, let's make some preparations. I'm going to track the meta informations like number of rows, number of columns, that is length of grid and length of grid 0. So the m is the number of rows and n is the number of columns. So with that said, let's maintain two lists, row means and column means. So this is going to store the minimum values so far. So we're going to use 1 times m and 1 times n. So 1 is the smallest possible value due to the problem requirement. So the grid ij is greater than or equal to 1, right? So that's why we use 1 here. So that's the first step for preparation. So next, actually, we do a sorting. So how do we do the sort? To fix the idea, let's use more space. I'm going to use this aux for, so I'm going to do this. So we're going to sort according to grid ij. So, but I want to track the index information or the position information. So for I in range m, and for j in range m. So this way, actually, we have a tuple, a list of tuples. So each tuple contains information about the value of at the current grid and the coordinates information. Then we can do a sort. So we can sort according to the first element. And then we can do the resetting. So next is the resetting. So for this, actually, we just need to traverse the aux list. So for I in range m times n, because this aux has length m times n, the total number of elements. So we set 1 by 1. And then let's first track the information for a current row and column. That is aux 0. The second and the third positions corresponding to the coordinates. So actually, the specific value of grid ij do not come into play. They just need provide our order in this sorting in step 2. So with that said, then actually we can set the grid value at RC. So because we need to maintain both the row and the column relative order, we need to use max here. So max row means at the current row, and row column means at the current column. So this way we finished resetting the RC position for the grid. And next, if we want to reset, we need to update the current row mean and column means. So for this, we are going to update row means R to be grid RC plus 1, and the column means C to be grid RC plus 1. So notice that this grid RC here and here is after the reset. In other words, the original value of the grid does not come into play specifically. So with that said, we are basically done. So finally, we can return the result. So for this, we just need to return the grid because we do the manipulation in place. So with that said, I guess that's about it. So let's do a special case check. So wrong answer. So let's see for I in range m. So here, so aux I, right? So let's change this one and test again. Yeah, it passes the example 1, I guess. Now let's do a generic case check. Yeah, it passes all the cases. With that said, let's give a quick summary. First, we actually reset the positions according to their values in the grid, so from small to larger. And secondly, we maintain a row and column means which help us to do the reset to make it as small as possible. In the specific code, actually we split into 4 parts logically. One is preparation, and the second is the main thing for sorting, and the third is the resetting. So this is the core of this code. And finally, we return the result. So with that said, I guess that's about it for this video. Thank you very much.